So in 6.6, we are going to use all of the log properties and exponential properties we looked at in 6.4 and 6.5 and use those to solve equations. And so I'm not going to say anything that you wouldn't have seen in some of these previous videos, but I'm going to use them intentionally, use those properties intentionally. What I can tell you is these problems take practice to get good at. It's like a puzzle. You're moving the pieces around till they fit just right and you can simplify things up. So just know that I've done these a bunch and I'm practiced, and you will get good as you practice them too. So I know that I can shift that leading coefficient up to be an exponent inside that log. And so that gives me log base 7 of x to the 1/2 power is equal to log base 7 of 2 to the 3rd power. And because I'm doing the same operation to both sides, log base 7 of and log base 7 of, that means the parts on the inside of the logs have to be equal to each other as well. And so I have x to the 1/2 power equals 2 to the 3rd power. Now, 2 to the 3rd power is 8, and just remember that x to the 1/2 power is the same as the square root of x. So to finish this off, I would simply square both sides, and I get x equals 64. And so that is the answer to this particular equation. When x equals 64, the left-hand side will equal the right-hand side. Next problem. So a lot of times in these, you want to combine those into a single log, and the product of logs, adding two logs being added. And by the way, this is log base 10. Anytime it doesn't give you a log base, it's just log. That is an understood base of 10. So this is log base 10 of x plus log base 10 of x plus 15 equals 2. So I can combine these into a single log. Because these are being added, I can multiply what's on the inside, x plus 15 there, and that still equals 2. Now, as I previously mentioned, this is log base 10, and I'm going to change this into its exponential form. An exponential form says the log base to that power, that's where the exponent is equal to what's inside the log. So that is x times x plus 15. Now, you may notice that this is going to be a quadratic, and so I have, if I distribute that there, I have x squared plus 15x is equal to 10 squared is 100. And if I subtract 100 over, I end up with a nice, neat quadratic. 0 is equal to x squared plus 15x minus 100 equals 0. Now, with this, I need to factor and solve. And so, if I can get this pin to work right, I have x plus or minus something times x plus or minus something. So I need two numbers that multiply together to be negative 100 and add together to be positive 15. And I believe that is going to be positive 20 and negative 5. 20 times negative 5 is negative 100. 20 plus negative 5 is positive 15. So now if I set each of those factors equal to 0, that is the zero product rule, it'll tell me the two numbers that will make this in fact equal to 0. And so the first one I get is x equals negative 20, and the second one I get is x equals positive 5. That's a little bit of work there that justifies that. And so those are my two solutions. Those two pieces give me possible solutions to this. Now, I do need to check one important note on there, and that is the fact that I don't think we can have a negative value. We can't have a negative input, a negative x value, because that is not in the domain. And so while these two are numerically come out to be true, our answer is simply the x equals positive 5, because we can't have a negative value to that. The last logarithmic function or logarithmic equation we're going to solve is this one right here. And so, similar to the last one, when you have multiple logs, you typically want them to be written in a single log, although these are on opposite sides of the equal sign. So I'm going to start by adding log base 8 of x of 4 to both sides. And on the right-hand side, that will neatly simplify out. And on the left-hand side, it's still going to be there, but it will be in a position that will allow us to clean this up. Oops. So those simplify out, and I have log base 8 of x plus 6 plus log base 8 of x plus 4 equal to 1, because that 1 is still sitting over there. And now similar to the last problem, I can combine those. And so they're both log base 8s, and so I can put those as multiplied together in a single log. That still equals 1. Now though, I can put this into its exponential form. So log base 8 to that power of 1, so 8 to the power of 1 equals x plus 6 times x plus 4. And once again, we're getting a quadratic. And if I multiply that together, I get x squared plus 4x plus 6x plus 24. All that junk is equal to 8. A little combining like terms, and I get x squared plus 10x plus 24 equals 8. I need this equal to 0, so I'm going to subtract 8 from both sides, and I have 0 equals x squared plus 10x plus 16. This factor's nice and neat. Two numbers that multiply together to be 16, add together to be 10. That's x plus 8 times x plus 2. And if I set each of those factors equal to 0, similar to that last problem, I'll get values of x equals negative 8 and x equals negative 2, which is an interesting problem, since both of those values are negative. I think that means, let me see here. Interesting. So check this out. If we plug in negative 8 back up here, that's going to give me log base 8 of a negative number. That doesn't check out. However, if I plug in x equals negative 2, if I plug it into both of these, because this is x plus 6, what's inside is still going to be positive. Because this is x plus 4, what's inside there is still going to be positive. So while it is a negative value because of the x plus 8 and the x plus 4, this actually does check out as a solution. So the difference being is that up on this previous one, when I plugged in negative 20 right there or right there, in either case, it's giving me log of a negative number, which we can't do. But in this case, the negative 2 value plugged in because of the shifts of those functions, that x plus 6 is a shift. Because of those shifts, this actually is in the domain, and the answer is x equals negative 2. So things you got to pay attention to. So one, you need to use your log properties to simplify these. A lot of times it will involve switching back into exponential form. And you got to pay attention to your answers. Do your answers make sense? Are they in the domain of the original problem? So for this one right here, x equals negative 8 is not part of the solution because it is not in the domain of that function, but x equals negative 2 is. And similarly here, the x equals negative 20 is not in the domain of the function. Can't take the domain, can't take the log of a negative number, but this right here does work just fine. So be aware of domain issues, but the bulk of this work is using all those log properties from 6.4 and 6.5.